What's up? Coach Bach here. We're talking about this research paper on myofascial force transmission. This paper is insightful, I would say, in that it clues us into some of the connectedness and complexity of soft tissue. What the researchers wanted to do was muscle force testing, but they wanted to maintain the anatomical connections of the muscle to the surrounding tissue rather than completely removing a fiber or a fascicle or a whole muscle and testing it in isolation, which is how a lot of our muscle force testing has been done historically. So the protocol was kind of gnarly. This was done on rats, of course. I'm going to try to communicate it with a little drawing here. You can certainly read all the details in the paper, although it's not an easy read. So they put the rat under anesthesia, then opened up the leg to access the musculature. And the primary muscle that they tested was the extensor digitorum longus. Okay. Now they cut the tendons on both ends of the muscle and attached them to force transducers to measure the force. Then here's the key: they left the rest of the muscle untouched. So any other connection to surrounding tissues remained intact. So let's just say hypothetically there's some fascial connection to, a neighboring muscle or a neighboring bone. Okay, something like that. The key finding was that the force in the tendons on the two different ends of the muscle is not necessarily the same. If you lengthen out one side, you get more tension on that side, both passively and if you activate the muscle. And then if you lengthen out the other side, you get more tension on that side, again, both passively and actively. Here's the graph that shows that key data. They tested at a range of muscle lengths, and you can see the force on the proximal and distal tendons is different. It's higher in the end of the muscle that is more lengthened. This can occur because some tension is held in the attachment of the muscle belly to the other surrounding tissue. So let's just say hypothetically you've lengthened out this end and you have, let's just say, 10 newtons on this end, and then on this end it's only 7 newtons, and that's because there's like 1 newton over here and 2 newtons over here and some of that additional tissue that attaches the muscle to other nearby structures. So this reveals some of the complexity of the myotendofascial system, right? It's not like you just have a muscle with an attachment on both ends and then the rest of it is just completely free. It's independent, it's isolated. No, there's actually more connectedness there. So the big question is, what do we do with this information? What is the impact this has on our training? I think the obvious implication is just understanding that just because a muscle is stressed by an exercise doesn't mean that the whole muscle is stressed equally, right? And this is something that you could probably just intuitively have known from an experience with muscle soreness, right? Like, okay, this exercise made me sore in, like this particular spot in the muscle and not the rest of it. Well, how does that happen? Well, because the stress, the tension is not necessarily the same throughout the muscle. The length, right? The amount that it's stretched out is not necessarily uniform throughout the whole muscle. Okay, so that's good. It's a good thing. It's an important thing to understand. And along with that, then you have to understand, if I want to train thoroughly, like let's say I want to make both of these tendons strong, well, I'm gonna maybe need to do 2 different exercises to do that, right? Or perhaps I can lengthen both ends all at the same time, and that could work. Okay, these are questions you would ask. And then also just the idea that, lengthening things out, you get more tension. And so then that's going to be good for developing your structure. So none of those conclusions are particularly mind-blowing. Again, you might have sort of instinctively or intuitively figured this out through practical experience. You could also look at all the research on regional hypertrophy, where you get different amounts of muscle growth in different areas of a muscle from different exercises. And that kind of reveals the same concept. So those are some clear and reasonable takeaways from this information. Now, what about fascia training? Does this research inform us at all on how to train fascia? Well, maybe you could go back to just that training at long length concept, right? Because we get more disconnect in the force when we stretch one end of the muscle out. So that tells us that we get more tension in this this kind of bridging tissue, this fascia that sort of connects things to neighboring structures. We get more tension there when we lengthen out one side of the muscle. And so, maybe there's, again, that conclusion like, okay, we should train at long length. Well, that's, of course, nothing new. There's no new conclusion drawn there. But yeah, perhaps training at very short muscle length doesn't really develop the fascia very much. That would be a reasonable hypothesis based on this information. Apart from that, does this tell us about how to bias training towards fascia versus muscle? Not really. Again, maybe just the long length, but we know long length definitely trains the heck out of the muscle too. Does this tell us about how we can train our muscles without really developing the fascia? No. I mean, again, maybe if you just go at all short length, right? That's not going to build up the structural framework of the muscle as much. Maybe we could draw that conclusion. Is there anything in here about, functional training or training fast versus training slow? Is there anything in here about barbells being bad? Is there anything in here about we need to train rotationally versus linearly? Like, sagittal plane is evil. Everything has to have transverse plane elements to it. No, there's nothing in here that you would get to those conclusions from. So to my fasciaists out there, I'm still waiting for some type of compelling evidence that shows us how any exercise is going to specifically develop the fascia, or how this exercise is going to neglect it or somehow dehydrate it or anything like that. You can get some good result with somebody, right? Like, okay, they came in with back pain and now they don't have back pain. Cool. That's happened 1,000 different ways. Okay. The question we're trying to answer is the mechanisms behind it. Does it have anything to do with biasing fascia in your training? Does it have anything to do with quote unquote functional training? Does it have anything to do with being rotational in your training? Or is, exercise and improving the capability of your body just generally good for people? If anyone out there knows of a study that might be interesting or insightful or help us answer some of these questions, let me know.